Hello and welcome to Maths with Jacob. This lesson will focus on Applying Differentiation Part 1. A special puzzle to warm up the brain cells is on the next slide. The answer will be given at the end. Enjoy. What is the meaning of the following? Good luck with it and see how you go. Calculus and differentiation. Differentiation is a form of calculus that enables us to find the slope of a line at a given point on a curve. Limits. We saw in earlier videos that limits help us to differentiate a given function from first principles. We saw that the limit of function x as x approaches a was function a. An example, the limit of 4x plus 2 as x approaches 3 is 14. Differentiation. Differentiating a function allows us to find the gradient of a line passing through a point on the graph of that function. Showing the gradient function. We saw that we could represent the gradient function in three different ways: dy dx, or function dashed x, or y dashed. Using first principles. A function can be differentiated from first principles using the following formula. dy dx equals the limit of function x plus k minus function k all over k as k approaches 0. We normally use the quick and easy way to differentiate a function. We only use first principles if we are specifically asked. 3 easy rules. When y equals c, dy dx equals 0. When y equals x to the power of m, dy dx equals mx to the power of m minus 1. When y equals cx to the power of m, dy dx equals mcx to the power of m minus 1. C and m are constants. An example using the above rules. If y equals x to the fourth plus 2x cubed plus 5x, dy dx is 4x cubed plus 6x squared plus 5. 3 very important rules. Firstly, the product rule. When y equals ux times vx, then dy dx equals u dv dx plus v du dx. The quotient rule. When y equals ux over vx, dy dx equals v du dx minus u dv dx over v squared. And the chain rule, when y equals function x all to the power of m, let u equals function x, then dy dx equals dy du by du dx. Finding the slope. If we are given a specific function and we want to find the slope of the tangent for a given point on the curve, we differentiate the function and substitute the given x value into the derived function. Example 1. Find the slope of the parabola y equals x squared minus 6x plus 5 at the point 4, negative 3. So function x equals x squared minus 6x plus 5. Function dashed x equals 2x minus 6. So function dashed 4 equals 2. So the slope of the tangent equals 2. So at that point there, the slope of the tangent equals 2. Example 2. Find the slope of the normal to the tangent of the parabola in example 1 at the point 4, negative 3. For this example, we can use the point gradient formula. So x1, y1 is 4, negative 3, and m is negative a half, because m1 times m2 is negative 1. So the original tangent had a gradient of 2, so the normal must have a gradient of negative a half. Because they're perpendicular, the product of their gradients is -1. So now we use the point gradient formula, and here's the information. x1, y1 is 4, -3, and m is -1/2. We substitute that information into the formula, and then we simplify to get to the next line. We simplify again by multiplying both sides by 2. We get rid of the grouping symbols, and we collect some terms on the one side, and the equation of the normal is 2y plus x plus 2 equals 0. Here's a quick quiz to help you. Please check through the video at any time. The answer to the puzzle. What is the meaning of the following? A person after my own heart. Wow, how nice is that? And here are the answers to the quick quiz, and the video is at your disposal.